and 4 corners, right? Okay, this is your answer. All right. Okay, now adjustment to the center line. So now we are starting to do some adjustment now. Okay, so now this is your center line. Now I want to know the length of this. What is the length of this? Meaning the internal length of the, if you look at the plan, what do you see? If you look at the plan, so this is your center line, which is this, right? Now you want to know the internal length, internal face. What is the perimeter like? So if I show you an overall picture, so now, just now you have this one, center line. Now I want to know what is the length of this one, the perimeter, the curve of the internal line. So you don't need to measure, you just need to do adjustment based on the center line. So this center line concept is important for you. Once you get your center line, okay, get your center line length and you do adjustment from here. You want to get this, you do adjustment. You want to get this, you do adjustment. You don't need to measure again. Okay. So you have outer trench, outer face of the trench and inner face of the trench. Get the term right so that when I teach you can follow me. So this internal line, internal face, right? So how do you do the adjustment? So now, trench required to be 515 mm wide. Okay? So okay, this has nothing to do with this drawing, okay? Because the trench here is 215. So let's talk about this trench here, the new drawing based on this drawing. The total trench dimension is 515. Alright? So first you need to know what is the center line first. Okay, so center line is 55140. Okay, let's see, 55140. They get the perimeter using the same perimeter but different trench, okay? Different trench size. Okay? Assuming the same dimension, you have the center line to center line 55140. Then you need to deduct half of the 550, right? This is your line. You want the internal ones, that means it will be shorter, right? So you deduct half of 5510, right? Because this length is, let me show it here. Sorry. So this one is the trench. Right? So now you have this line, okay, total length is 5514, is it? Plus 55140, is it? Yes. So if you go inside, it will be shorter, right? So this one is your center line. So this one definitely will be shorter, longer than this one. So it will be shorter. So basically, you take this one. You need to take 55140, deduct, okay, 4 times 2 times half times 515. You need to deduct it, okay? Because you need to deduct this corner, okay? Every corner, this corner. Deduct this corner. Then you get the length. So basically, you don't need to measure. 515 half. Okay. So then now, meaning internally, the length here is internal 53080. The center line is the curve 55140. So if I want to do the external line, what do you think you will do? So that is why it's important to get the center line. What will you do? You are going to add. Very easy and very fast, without any measurement needed. Yes, Dane?
The center line, the 55140, is the whole rectangle or is it just one line?
The whole rectangle. Why do I say it's the whole rectangle? Because when you was doing just now, it's like 2 times 9, 2 times 19. Then only you have that 55140. So it's the perimeter. That's why we call the term is curve. Total around. And it's in meter. Okay, it's in meter. Vivian, can you follow? Yeah? Okay. Very easy, right? So we go to the what do you say? The substructure taking off now. This is just a concept. Okay? There are some videos in the thing, in the vision. You can actually have a look at the vision and look at the video. Basically, this is about the same. You can have a look at the handbook as well. If you don't understand, you can ask me questions. So the reason why I want to go through the thing very quickly with you, because as you know, there's this coronavirus thing, right? So I'm a bit concerned that they want to shut down. If there's any case, if there's any positive case, they need to shut down for at least 2 days for sanitizing. So it might affect our, progress. So I try to finish all the lecture. So please bear with me. If you don't understand, you ask me during the lecture. But about the tutorials and all the additional read up, please do it at home. Okay? Then you can ask me after the lecture. Alright? So this one, there are some projects that you can do for the calculations. I hope that you can do this calculation as well, so that we can discuss as well tomorrow tutorial. Okay? So let's keep the thing moving. So because you have learned the concept of center line, let's do the measurements of the foundation first. Okay, class, try to understand this substructure thing, because this is one of the elements that is important to you for excavation, which you might not be learning in your measurement 2 later on, right? So your measurement 2, you'll be measuring roof, steel structure. So get the concept right, okay? So substructure works measurement, right? So what do you do? This is a few of the things that you will do first when you come to a site, right? Before you even talk about floor finishes, before you even talk about erecting the walls and whatnot, right? So the first thing that we do is to do site clearance, right? Like what I said, you observe the site across the road. So class, do you know what are they doing there?
Yes.
What is that?
Time.
It's a time gallery.
Yeah.
So it's a gallery. So I think that sometimes, previously we don't have much problems bringing students to site. But with the because due to safety, health and safety, the site tend to be very cautious nowadays. That means the project site, people are very cautious. So they don't allow like 40 or 50 students to visit a construction site. So it's kind of challenging for us to actually bring the whole group of people to the construction site nowadays. Yeah. So, and also there's not much work nowadays. Yeah. There's a lot of, some might not be, the stages might not be relevant to you. Maybe some project that we have is almost completing. When you go in, it's just looking at the finishes only, which is quite safe for you to visit. So, not much new projects, so naturally you will know that it's difficult to find like during the substructure stage, during the framing stage and whatnot. So, since we have a project just across our road, I really advise you to really get this opportunity, not just for this module, but also for you to understand your construction technology and also your measurement tool in future, right? On keeping track, or maybe doing some, taking some photos for you to understand the process from A to Z, which is very important. You can really start your own scrapbook and do your recording, so that it's easier. So this one, it's a building, so it's good. Previously, I shown my student about the example of how they do the car park, but it's just a car park, so they just stop there. But this is a construction of a building, which is very, very good, right? So now, first stage, site clearance. The next stage, they will start excavating. And if you notice that, I think, if I'm not mistaken, the water table here is quite high. You might have the opportunity to see how they pump the water out, because before they start doing their groundworks. Because I saw the car park, they actually have extraction of water from the ground after they excavate. So that is also one of the elements that I'm going to teach you in this substructure taking off, so that you have a better idea. But having said that, even you're not going to wait for this one project only, right? You can always Google your YouTube and study from your YouTube. Now you have videos, it's so much convenient. Okay? Session 11. Session 11. Okay, now, the substructure foundation. The substructure is defined as the work below the waterproofing works. So that means, because the soil is moist, whether your water table is low or high, or it doesn't matter, because any soil will have that moisture, okay? So they will actually evaporate through your concrete. So anything which is on the ground floor will have a layer of waterproofing works. And in this scenario, we normally call it as DPC or DPM. DPM is the membrane for the whole slab. DPC is a membrane on the walls, on the vertical elements. So it's called a dam-proof course. So all foundation construction works or items up to DPC level should be measured as per NRS2. Okay? So let's look at these drawings. Okay? This one is your ground level. In fact, this is a very good drawings to visualize. So this is ground level. You have done all the necessary site clearance and all those. And this is a flat site. And you want to start doing your foundation, right? So what you do is, you will do, the first step, you can do this excavation. You have to do this excavation, okay? This step. After you have done your excavation, what do you do? There are things that you cannot see from here, but you need to do. For example, you excavate, where do you put your soil? You need to measure that. Are you disposing your soil off-site or within the site? What is the difference between off-site? Means after you excavate, you will send it outside of your site. So the rate is different. So disposal of soil off-site and disposal of soil within the site It's two different items that you need to measure separately. Okay, so when you excavate this, if the soil is suitable, you will use the soil back, you will reuse the soil to fill in here for filling. That one you can save more money. But if the soil is not suitable, what you do? You need to fill in with imported soil. And that is another rate, a different rate. Right? So there are so many items that you need to break it down, dissect it down. That's why I say, being a QS, you must be very detailed, systematic, so that you know what you're doing. And you need to know the procedure. So, okay? Then, you start to do the concrete foundation. So concrete, we have what? What do we have? We have concrete. Because it's a ground floor, we might not need a formwork, but at the edge, you need a formwork. You pour your concrete. Reinforcement bar. Okay, when we talk about concrete, there's three items. Concrete itself, formwork, and rebar. Rebar means reinforcement bar. Okay, these three items will come together when we talk about reinforced concrete. Alright? So, your reinforcement, how to do your measurement for your reinforcement will be taught in measurement, the next measurement, okay, in your next module. Right? So, in this case, we are going to do a strip footing only. Okay. Then you will have to erect you erect the walls, all the necessary, and you will have to fill it. So this is the dam-proof membrane. Okay, this is the engineering bit. This is the block work, and this is the ground floor, strip footing, with concrete filled to ground. So this is just a concrete just to fill it. Okay. So this is just an introduction. Oh, what is this? So now look at this one, class activity. With reference to the following drawing, M100 and NRM section 2 section 5, excavating and filling, identify the items to be measured and prepare the taking off list. So what are the things that you need to take off for this section 5, excavating and filling? So this is the process, okay? Okay, this is land survey, site survey. So this one they are building the blocks already.
This house built a
So soft.
the oak frame is made from a series of posts and beams connected by sophisticated carbon joints. The panels sit on a low plinth of stonework, which keeps the frame